Today's objective is to find and apply the midpoint between 2 points. All right, let's look at this red triangle here with vertices at A, B, and C. And we'll start with points A to points B. If we're trying to find the midpoint, let's look and see this using our eyes before we get to the math. It looks like the middle is right here between A and B. 1, 2, 3 spaces from A, and 1, 2, 3 spaces from B. What coordinate is that? The coordinate is 5 for X and 6 for Y. If we look at B and C, where is the midpoint of B and C? Again, looking at spaces, it appears to be right here. 2 spaces down from B and 2 spaces up from C. That coordinate is 8 for X and 4 for Y. Okay, well now we have to deal with this diagonal, which is a little more tricky. Well, if we look at how we got the answer for the midpoint of A to B, there's a pattern of how I got the 5. The 5 came from adding 8 plus 2 and cutting it in half, meaning the middle is the midpoint, which is halfway. And 8 and 2 is 10, and half of 10 is 5, which gave us the 5 for X. Y is still 6, it's on the same line, it's the same number. For the midpoint from B to C, we have 8 comma 4. 8 is the same, it's on the same line, but where does the 4 come from? 4 is between 6 and 2. It's in the middle of 6 and 2. 6 and 2 is 8, and halfway, the midpoint in the middle is halfway. Half of 8 is 4, which is where this 4 came from. And if we combine these steps to find the midpoint of the diagonal, I need to find the midpoint of the x's, and the x's are 8 and 2, which we already calculated. Between 8 and 2 is 10. Right here, the first one we did, which is 5. And the midpoint between B and C was when Y was 4. Between 6 and 2 is 4, and the midpoint would be right here of the diagonal AC. If we put all of this together, we have a rule to figure out how to find midpoints of any line, whether it's horizontal, or vertical, or diagonal. That rule is called the midpoint formula. If you have 2 points A and B, you can find the midpoint M by this little ordered pair rule right here. We have the x-coordinate is just add up the 2 x's and divide it by 2. The y-coordinate is just add up the 2 y-coordinates and divide by 2. It's in the middle. It's the average, or halfway. Let's look at a couple of examples. E. What is the midpoint from A to B? All right, so the midpoint of A to B. How do I figure that out? It's halfway between the coordinates. It's halfway between the x's. The x's are 0 and minus 3. So 0 and minus 3, and it's halfway, divided by 2. The y-coordinates are minus 1 and 5. We have minus 1 and 5, and it's halfway. The final ordered pair for the midpoint, 0 and minus 3 is minus 3. Minus 3 divided by 2 is minus 1.5, which is minus 3 over 2. The y-coordinate is -1 and 5, which is 4. 4 divided by 2 is 2. There's the midpoint. Let's look at another one. G. Again, what is the midpoint of A, B? And again, if you want to find the midpoint of each coordinate, add up the same coordinates. The midpoint of the x's between -4 and 9. -4 and 9 divided by 2, halfway. The y's are 3 and 5, so halfway between 3 and 5. Simplifying the fraction, -4 plus 9 is 5. 5 divided by 2 is 2.5. 2.5. That's 5 divided by 2. 3 plus 5 for the y's is 8. 8 divided by 2 is 4. And the last one, I, again, midpoint of A and B. This time it looks like all the values aren't there, so it will just be a little formula. The midpoint of the x's. X's are A and 2. All right, halfway between A and 2 is A plus 2 divided by 2. Halfway between the y's, 5 and -1, 5 and -1. Halfway is A plus 2 divided by 2 is A plus 2 divided by 2. It cannot be reduced. 5 minus 1 is 4. 4 divided by 2 is 2. That is the midpoint. Okay? Now we're going to look at midpoint when values are missing and when we don't have all of the data. M is the midpoint of P to Q. So I'll make a picture for you to make it easier to see. P, Q, and in the middle is the midpoint M. P is at 3, 1. The midpoint, now be careful here. The midpoint is 1 and -3. Q, I don't know what that is. Okay? This we have to think a little differently. The midpoint is adding up the P and the Q, right? P is unknown, it's X and Y. Remember what we just did? We'll write this out. The midpoint of P, Q equals, let's just write out the rule like we did before. PQ. First the x's for P, x is 3, plus x over here for Q, well, I don't know what that is, x. Halfway. The y's, P is 1, and the y for Q, I don't know, and halfway. Okay, so that's what the rule looks like written in. But we know the answers. The answers for x has to be 1 for the midpoint. The answer for y, the y-coordinate has to be, midpoint is -3. So let's check these. We make a little rule. The first one, the x, this one, when I do this work, has to equal the midpoint. And the midpoint answer for x is right there. Likewise, when I do the y-coordinate of the midpoint, the answer is right there at -3. So we set each of these as separate little problems. 3 plus x divided by 2. That's the midpoint rule. But I know what the answer is. It equals 1. So I solve this equation. If it's dividing by 2, I multiply both sides by 2. The 2's will cancel, and I will get 3 plus x equals 2. solving for x, instead of adding 3 to both sides, we will subtract 3. X equals negative 1. Okay? Now, we will find the y-coordinate of q using the idea that the midpoint is adding up the y's, which is 1 plus y, halfway, and I know what the answer is. The midpoint for y is negative 3. So I make it equal to negative 3. Same steps again. Dividing by 2. What's the opposite of dividing by 2? We're going to multiply both sides by 2. 2 over 2, that cancels. That gives me 1 plus y. The 2's cancel. Negative 3 times 2 is negative 6. And not adding 1 with y, subtracting 1 from y to both sides gives me y equals negative 6. And negative 1 is negative 7. So this coordinate q should be x is negative 1 and y is negative 7. Okay? I'll do one more of those for you if you would like. You can always skip around through this video at any time. Find the value of p so that negative 2, comma 2.5 is the midpoint between p2 and negative 1, 3. Again, it will be helpful maybe to make a little diagram. Make sure we're labeling and putting the right points together. Find the value of p so that negative 2, comma 2.5 is the midpoint. So the midpoint should be negative 2, comma 2.5. There is the midpoint, okay? Between, and I have two values. P, put P here. What is this? This is P, comma 2. And the other coordinate down here is negative 1, comma 3. Okay, so the diagram should help you decide how to work through midpoint. Midpoint is add up the x-coordinates. So we'll do the x first. X is our first coordinates. So one endpoint is P plus the other x-coordinate at the other end is negative 1. If I take half of that, it should equal the x-coordinate for the midpoint. Likewise, if I'm going to find y, if you look, I guess I don't need to find y, do we? We have the y-coordinate of 2, the y-coordinate of 2.5, and this other y-coordinate of 3. Y is already found. So the only point missing is p. So again, how did I set this up? P goes with the minus 1. Those are the two x-coordinates. So p and negative 1. Halfway, the midpoint, right? Halfway, so divided by 2. And the answer is given with the midpoint of minus 2. We can multiply both sides by 2 to clear the fraction. 2 divided by 2 cancels. This gives me p minus 1 equals negative 2 times 2 is negative 4. Not subtracting 1 to both sides, add 1 to both sides. P equals negative 4 and 1 is negative 3. Now I have found the value of p. Same thing, find the center of a circle with a diameter having endpoints of negative 4, 3, and 0, 2. A little geometric application. There's a circle. Diameter is straight across through the middle. And we have two endpoints of the diameter. Negative 4, 3 is one endpoint, and this other endpoint is 0, 2. So find the center. Well, the center of a circle is in the middle. So the center of a circle is the midpoint. So I apply the midpoint formula. So the center of the circle would be add up the x coordinates, which are -4